AI scripting. Welcome to our demonstration of the latest AI-powered enhancements in Copilot. With intelligent Python scripting now specifically trained for CAD design, we've introduced 3 major upgrades that bring powerful new capabilities to your workflow. First, you now have access to an AI model trained on over 400 Python CAD examples. This gives you a helpful assistant that can guide you through writing scripts and help you understand how to create custom CAD geometry using code. Second, we've added a powerful AI agent that can execute Python scripts and turn them into accurate 3D models. You simply provide the instructions, and it generates precise CAD data based on your input. Third, there's a new object type that lets you edit script parameters directly in the interface. This means you can quickly adjust values and instantly see how they affect your design, allowing for fast exploration of different ideas. Let's walk through how these tools work together in a real-world example. We'll add a custom thread to a cylinder using AI-generated scripting. To start, we'll ask Copilot to generate a sample script by typing a simple request. Provide a Python script to create an external ISO standard thread and add it to a cylinder. The AI responds with the correct code for the task. You can then take that response, paste it back as input, and ask the AI to refine or modify it further. This allows for interactive development of your script, making it easier to get exactly what you need. Once the part is created, you can modify it by adjusting key parameters like thread pitch, diameter, and length. Each change updates the model automatically, so you can explore variations without rewriting the entire script. Arc Slot Tool. The Arc Slot Polygon tool is a versatile feature that allows you to create precise arc-shaped slots for various applications, such as adjustable mounting brackets, curved hinge mechanisms, ventilation louvers, and decorative grill patterns. This tool provides the flexibility needed to design intricate and functional components with ease. To access the Arc Slot Polygon tool, navigate to the Polygon tool palette located on the right side of your interface. The tool is represented by the last icon in the palette. Let's proceed to create an arc slot. Begin by specifying the start point, end point, and a point along the middle of the arc. After defining these points, set the width of the arc to complete the initial setup. Once the basic arc slot is created, you can refine its shape and dimensions using the Edit tool. To adjust the points that define the arc, select the arrow tool and drag each point to new positions. This allows you to fine-tune the curvature and alignment of the slot. For further customization, you can also modify the width of the arc directly via the data entry window. Additionally, you can adjust the arc angle to achieve the desired curvature. Let's change the arc angle to 140 degrees for this example. Batch export, 1 file per part. Welcome to this tutorial on how to use the batch export feature. In this video, we'll guide you through the process of exporting each part of a file as a separate file. This feature is incredibly useful when managing complex assemblies or projects with multiple components. Let's get started. To begin, open your project file in the application. In this demonstration, we'll be working with an assembly containing multiple parts. Once your file is open, navigate to the File menu at the top of the screen. From the File menu, select Batch. This will open the Batch Files window, where you can configure your export settings. The Batch tool allows you to automate the export process, ensuring efficiency and reducing errors. In the Batch Files window, you'll find several options under Import Options and Export Options. For this tutorial, we'll focus on exporting each part as a separate file. Choose the file format for exporting. Common formats include 3MF, STL, and OBJ, depending on your needs. For this example, we'll select 3MF as the export format. 026 under Miscellaneous Options, check the one file per part box. This ensures that each component in the assembly is saved as an independent file. You can also fine-tune additional settings, such as creating subfolders or deleting original files if needed. Once all the settings are configured, click OK to proceed. The program will now process the file and export each part separately. This may take some time for larger assemblies, but you'll see progress updates on the screen. After the export is complete, navigate to the designated output folder to verify the exported files. You should see a neatly organized list, with each file representing a different part of the assembly. This structured approach makes it easier to manage and share individual components. To ensure the exported files work correctly, import one of them back into the program. Go to the File menu and select Import. Choose the desired file format and locate the file you just exported. Once imported, you can rotate, inspect, and compare the part to the original design to ensure accuracy. That's it. You've successfully used the Batch Export feature to export each part of your assembly as a separate file. This powerful tool saves time, ensures accuracy, and keeps your workflow organized when working with multi-component projects. File loading performance. Welcome to this exciting demonstration of how version 16 revolutionizes file loading performance. If you work with large CAD files, this update is a game changer. Let's dive into the details and see how much faster your workflow can be. The need for speed. Version 16 introduces a breakthrough in file loading speeds, achieving up to 22 times faster performance for large files containing thousands of entities. This enhancement is designed to streamline workflows, reduce wait times, and boost productivity. Old versus new, a dramatic difference. Loading large files was a time-consuming process, often taking several minutes. During this time, users were left waiting as the software processed the data. The same large file now loads in just seconds, making the process nearly instantaneous. This dramatic improvement ensures that you can start working on your designs almost immediately. Why this matters. No more staring at progress bars or twiddling your thumbs. With version 16, you can focus on what matters, designing. Reduced loading times mean you can iterate faster, make changes on the fly, and meet tight deadlines without frustration. Smoother transitions and quicker access to your files create a seamless and enjoyable design experience. Unlock your potential. Whether you're working on intricate architectural models, complex assemblies, or detailed mechanical designs, version 16 empowers you to handle large files with ease. This performance boost isn't just about speed. It's about transforming the way you work, giving you more time to innovate and create. Conclusion. Version 16 delivers unparalleled file loading performance, reducing wait times by up to 22 times for large files. This enhancement ensures smoother workflows, increased productivity, and a better overall user experience. File redraw performance. The latest update delivers significant performance enhancements, particularly when working with large 2D files. In this demonstration, we're showcasing a complex drawing containing over 148,000 entities, such as points, lines, circles, polygons, text, and groups. On the left, you'll see the previous version in action, while the right side displays the updated version. As we zoom in, observe the repaint time. The previous version experiences noticeably slower redraws, which can impact workflow speed and responsiveness. Now, let's compare it to the updated version. You'll see that the repaint time is significantly faster, providing a smoother and more fluid experience. This improvement is especially beneficial when handling intricate designs, allowing for quicker interactions and enhanced productivity. By leveraging these advancements, users can enjoy a more efficient and responsive experience, enabling them to focus on what truly matters, creating precise and innovative designs. Improved custom tool creation and editing. Welcome to this tutorial on creating and editing custom tool palettes. In this video, we'll show you how to optimize your workflow by efficiently organizing your tools, creating new palettes, and tailoring their layout to suit your needs. Let's dive in. Go to the Tools menu at the top of the screen. From there, select Custom Tools, then choose New Palette. This will open the Custom Tools dialog box, where you can configure settings for your new palette. In the Custom Tools dialog box, you'll find options for name, columns, rows, and icon size. Start by naming your new palette. For this example, we'll call it Test. Next, set the number of columns and rows to match your organization preferences. You can create larger arrays such as 3x20 or 10x10 for better structure. In this demonstration, we'll set the columns to 5 and the rows to 7. Click OK to create the palette. Now that your palette is created, you can begin adding tools to it. To edit an existing tool, right-click on its icon within the palette and select Edit Custom Tool. The Custom Tools dialog box will reopen, allowing you to modify key properties such as name, icon, and size. Make the necessary adjustments and click OK to save your changes. Now, drag and drop the desired tool from an existing palette into your new custom palette. You can also adjust icon sizes to improve visibility and accessibility. Right-click on a tool and select Change Icon Size to resize it to your preference. This feature helps maintain a clean, organized workspace tailored to your needs. That's it. You've successfully created and customized a new tool palette. The ability to organize tools into structured arrays and make precise customization ensures a more efficient and intuitive workflow. Whether you're working on architectural designs, mechanical models, or any other projects, these features help you focus on creativity and productivity without worrying about tool management. ISO Part Library. The ISO Part Library is a powerful tool in your CAD software that provides a comprehensive collection of standardized mechanical components, ensuring accuracy and efficiency in design processes. In this tutorial, we'll focus on exploring the ISO fasteners section and demonstrating how to select and place threaded nuts in your projects. Let's get started. Open the Explorer window and expand the ISO fasteners category to access a wide range of fastener options. Select the hex nut threaded option. Drag and drop the symbol into the workspace and position and orient the nut for your design needs. Choose the Hex Brad T Nut Threaded option. Place it in the workspace and show its unique features compared to the standard hex nut. Let's explore different fastener components available in the ISO part library. All parts comply with ISO standards, ensuring compatibility and reliability across industries. Pre-built, precision-modeled parts eliminate the need for manual design, speeding up your workflow. Highly detailed 3D models provide realistic previews, helping you visualize how parts fit together before finalizing your design. Each part is accurately modeled according to specifications, reducing errors and rework. Part Creator. Welcome to Part Creator, an intelligent AI-assisted CAD tool designed to redefine 3D part creation. This tool is specifically tailored for engineers and designers, leveraging AI and Python scripting to deliver highly accurate parametric models. From gears to nuts, screws, and custom threads, Part Creator streamlines your workflow with precision and flexibility. The application supports over 20 parametric parts, offering intelligent editing capabilities, text-to-CAD functionality, and an AI assistant to help you create Python CAD scripts. Part Creator offers extensive gear modeling capabilities, supporting a comprehensive range of gear types, including spur, worm, bevel, rack, herringbone, ring, and planetary gears. You can precisely model complex parametric gears with full control over key parameters such as tooth counts, ensuring they meet your engineering design needs. The application also provides comprehensive ISO nut modeling capabilities, supporting a diverse range of nut types, including hex, flange, jam, square, domed cap, brad tee, heat set, and unchamfered hexagon nuts. With detailed control over parameters like size and thread pitch, you can create parametric nuts that perfectly fit your engineering and design specifications. Design ISO-compliant screws in numerous styles, including hex head flange, countersunk, cheese head, button head with collar, pan head with collar, raised cheese head, raised countersunk, oval head, set screw, and socket head cap screws. Gain precise control over essential parameters such as length, thread size, and head type to ensure a perfect fit in your designs. Part Creator allows you to create robust, precise interior and exterior threads for your design applications. Define critical parameters such as pitch, major diameter, and length to achieve the desired thread specifications. The application supports ISO, ACME, metric, trapezoidal, and general threads, enabling you to enhance your designs with an array of smaller yet essential mechanical components such as chains, sprockets, I-beams, and pipes, all crafted through Part Creator's highly configurable parametric approach. Watch this category grow as more training data is integrated. Each part created using Part Creator stores the instructions or Python script used for its creation. Select the part in the inspector to review or edit parameters and regenerate your part as needed. Parts can also be created using the Copilot PPT AI agent. This agent is trained to take textual commands and convert them into Python scripts, which, when executed, create the precise part you need. Try out Part Creator and select from over 20 built-in parametric parts, create new parts using text-to-CAD, or execute custom Python scripts. Sheet metal tools provide a comprehensive and powerful set of features for designing and working with sheet metal components with high precision and efficiency. The tab feature in sheet metal is used to create a flat, protruding section that extends from the base or flange of a sheet metal part. This extension typically lies in the same plane as the surface it originates from and can be rectangular, trapezoidal, or customized based on design requirements. The tab feature often serves as a foundation for adding additional sheet metal elements. To use the tab tool, select it and apply it to a closed profile. This will generate a 3D shape from your selected sketch. You can adjust the thickness by entering the desired value directly into the thickness field. The bend feature allows you to shape a flat sheet metal piece into a curved or angled form while preserving the material's structural integrity. This tool is essential for creating parts such as brackets, enclosures, and ducts. To use the bend feature, select the tool and define the bend axis by choosing 2 points on the face where the bend will occur. The unbend feature enables you to return a bent or curved section of a sheet metal part back to a flat, planar state without altering the overall design. Select the unbend tool and then choose the solid geometry you wish to unbend. The hem feature lets you fold the edge of a sheet metal part back onto itself, forming either a rounded or flat lip. This enhances strength, improves safety, and gives a cleaner appearance. To apply a hem, select the single hem tool, then choose an edge of the solid where you want to add the hem feature. Adjust the length and gap values by entering your desired measurements into the respective fields. The flange feature allows you to add a straight, planar extension or lip to an existing edge of a sheet metal part. Flanges are commonly used to reinforce structures, connect parts, or provide mounting surfaces. Select the edge of the solid where you want to add the flange, then define the bend axis by selecting 2 points. Set the length, radius, and angle by entering your preferred values into each corresponding field. The contour flange feature enables you to create complex sheet metal shapes by extruding a sketch profile along a defined path using 2 points. The profile can include lines, arcs, splines, or elliptical arcs. Sharp corners in the sketch automatically generate bends based on the bend radius specified in the sheet metal style settings. Select the contour flange tool, then choose the sketch lines you want to extrude into a contour flange. Define a direction and length by specifying 2 points. SketchUp import. Welcome to this tutorial on importing SketchUp files into your application. In this video, we'll walk you through the simple steps to integrate your SketchUp models seamlessly. Let's get started. First, navigate to the File menu at the top of the screen and select Import. In the Import dialog box, locate SketchUp from the list of available formats, then click OK to proceed. Next, browse to the location where your SketchUp file is saved. For this demonstration, let's assume the file is named table.skp and is stored in the Downloads folder. Select the file and click Open. The program will now process the SketchUp model. You may see a progress indicator as the file is imported. Once completed, the model will appear in the workspace, ready for editing. Now that the model is imported, you can start refining and working with it. Use the various tools and features in the software to modify, enhance, and develop your design. For example, adjust the camera view or zoom levels to get a better perspective on your SketchUp model. That's it. You've successfully imported a SketchUp model into your application. The Enhanced SketchUp importer ensures that your designs are accurately represented, with significant improvements in handling materials like transparent surfaces and glass elements. Whether you're creating architectural models, product designs, or other projects, this integration streamlines collaboration between SketchUp and your application. Thanks for watching. If you found this tutorial helpful, don't forget to like, subscribe, and share. Happy designing!